recording the vodcast for our practice test. My name is Ramsey. How y'all doing? I'm in blocks 2, 3, 5, and 6. Yay. Okay, I'm going to do the multiple choice video in this first vodcast, and then I'm going to do the free response in the second one. We look at this first vodcast and we see energy diagrams. It's important to go ahead and just analyze them first. We know that's endo, exo, we know that's endo, that's exo, that's endo, and this is endo. If you're endo, you end up higher. If you're exo, you end up lower. Which one has a large activation energy? Activation energy is E sub A. It's the height of the initial hill. The one with the largest activation energy is going to be this one, C. This is the most exothermic reaction. The most exothermic reaction is the one that's going to have the largest difference between beginning and finishing, and you're going to end lower. So that's going to be A. Delta H is very less than 0 for A. And the largest positive delta H, well, that's the opposite of this one. So these two are opposites. So let's go through and find that. The largest positive delta H, that's going to be D. Delta H is very large in that case, endothermic reaction. So CAD, CAD, CAD. Here we go. All right. This next problem is a heating curve. In a heating curve, it's the plateaus that we're really concerned about. That's where the phase changes happen. According to the diagram, where is it melting? Let's go and add some states. That would be where it's solid. That's where it's a liquid. If there was a line up there, that would be a gas. And we know that melting is a conversion from a solid to a liquid. So that's going to happen here at time T2. B. All right, so we see some delta H's flying around. We think about our flow chart. We got the bond category. We got the formation category. And we got the steps category. I do see a little F here, so this is going to be in the formation category. So delta H is going to be equal to the sum of the products minus the sum of the reactants. We know that these are products, these are reactants. So I'm going to open up here to the key so we can follow along. That's going to be 1 times the C6H6 value minus 3 times the C2H2 value. And when you plug in these numbers that you have here, when you plug in the 83 into there and the 230 into there, you end up with a negative 607 kilojoules per mole, giving us A as the answer. All right, looking at 6, we've seen these before. So we're going to be identifying delta G, delta H, delta S. We know that delta G is, we're going to be looking for spontaneity. With delta H, we're going to be looking for heat. And for delta S, we're going to be looking for messiness. So it says these are mixed and the temperature drops and a gas is produced. This happens naturally, so we know that delta G is going to be negative in this case. It says the temperature drops. Okay, if we have a drop in temperature, it's endothermic, so that's going to be positive. And it also says a gas is produced, so it gets messier. So we got a negative, positive, positive. B's the no, C is the answer. All right, 7. Which of the following must be true in a reaction in which the activation energy is the same in both the forward and the reverse? So we know that the activation energy is the height to the hill. Okay, that's E sub A. Now, if this is the forward reaction, for it to be the same in the reverse direction, you must have started from the same height. So, if it's the same here as it is here, that means the difference from where you started and when you ended is the same. So, delta H in this case is going to be equal to 0. That's going to be D. Okay, we got another graph. We're looking at the plateaus in this case. It will actually ask us here, where are they moving the slowest? So we know in terms of speed, we have gases, then liquids, and then solids. These move fast, and these move slow. So we're looking for the solid area, so that's going to be wherever we are the lowest on this chart. So E is going to be the answer there. Solids have the lowest temperature. Okay. Largest decrease in entropy is the one with delta S is the most less than 0. And we know that if delta S equals a negative, we're talking clean. And gases are messy, liquids, solids, this is a messy side, this is the clean side. So E is the answer. You go from a solid and a gas to a solid. Everything else is either delta S 0 or it's actually getting messier. For instance, in this reaction, 6 gases make 7 gases. In this reaction, a solid goes to a gas. All right, 10. 10 is a great problem. Okay, I really like 10. It says a certain reaction is spontaneous at temperatures below 400. So if you have 400, its delta G is negative. And it says, but it's not spontaneous at temperatures above 400. So it's spontaneous only at low temperatures. So delta G is positive below and positive above and negative below. It does tell us if delta H equals negative 20 at 400 K. And it is assumed that delta H and delta S do not change that much with temperature. What's the value for delta S? Well, the only equation we have that relates all of these things is gotta hate this stuff. Now, here's the deal. They want a certain reaction is spontaneous at temperatures below 400, but not spontaneous above. So we can assume that kind of at 400, this is an assumption that at 400 K, delta G is equal to 0. So anywhere above 400, it's going to be positive. Anywhere below 400, it's going to be negative. So this is the assumption we're making in order to do this problem. So we're going to say 0 is equal to negative 20 minus 400 times delta S. And delta S is going to be equal in this case after we solve for it, and it's a little tricky in this case because delta S is going to come out in units of kilojoules, 0.05 kilojoules mole Kelvin, but you always got to convert it to joules, so that's going to be 50 joules per mole Kelvin, giving us a negative 50, giving us A as the answer. This is a tempting answer here, but notice the units are in joules. It's 0.05 when it's in kilojoules per mole Kelvin. So look at this problem over and over. It's a really good one to focus on. All right, in 11, I see delta H's. I don't see bond. I don't see the word formation. So I'm looking for steps. I do see my steps. In this first step, SO2 should be on the left. So delta H equals X plus Y. SO2 should be on the left, so we got to make a negative here, and it should be multiplied by 2. So I got to put a 2 up there. On this one, SO3 is on the correct side, but it should be multiplied by 2. So negative 2x plus 2y is the same thing as 2y minus 2x, making the answer E. For 12, there's my bond. So delta H equals sum of broken minus sum of formed. I'm going to draw my Lewis structures here. Should pop out that that's not balanced. So broken is the H2. So one of those H2s is broken at 440. And one of those Cl's is broken at 240. Minus 2 of those hydrochlorics are broken at 430. So this is going to give us a negative 180 kilojoules per mole. Answer D. Okay, see you on the free response, guys. Take care.